So, in comparison to the Grignard reaction, the Barbier type organozinc reaction is considered to be a little bit more green. So, we've already talked about one Grignard reaction, that was the Wittig reaction. So, this is not a solventless reaction like the Wittig reaction that we did, but it does use water as its main solvent rather than the ether solvent that we use for the Grignard reaction. The two reactions are very similar. You make an organometallic nucleophile and you add it to a carbonyl compound. In this case, we're taking allyl bromide, adding a zinc in between the carbon and the bromine, and making that compound, an organozinc compound, and adding it to 3-pentanone. So you are still going to be making a alcohol as a product, in this case a tertiary alcohol. So the reactions do function in a very similar way. However, the nature of the reaction, because we're using zinc instead of magnesium, the organozinc compound is much less basic, and so you can actually use water as a solvent or co-solvent in this reaction. So you actually use it as a co-solvent with THF. You actually have saturated ammonium chloride as part of this, so it's a very complicated set of different mixtures for the reaction, but the reaction itself does lower significantly the amount of organic solvents that you use through the experiment. So we do consider this a somewhat green version of a Grignard reaction. Now, the reason why we don't use this as a replacement is that the two reactions don't function exactly the same way. There are certain starting materials that work better with the Grignard reaction. There are certain starting materials that work better with the organozinc reaction. So it's not a direct replacement reaction. But it's important to look at the differences between the two. So you're still taking a halide and a carbonyl compound and a metal and combining them together in some way to make an alcohol product or a tertiary alcohol product. So they are very similar reactions. So it's important for you to look at the differences between the two, both in how they operate, the experimental operation of the reaction, and the mechanistic operation of the reactions as well. So it's a very interesting comparison.